Okay, so we're looking at the practice paper from the first year textbook, and I think we're on question 6. Yes, and we're on, what's happening? Right, here we go. Okay, we're on question 6. Right, so we have got, well, it looks like a cubic, but actually when we've got this 1 over x squared term, so it's an unknown function. And we are told the x coordinate of point P, and we ask the equation of the normal, and then when we get to our final answer, we just need to make sure it's in the correct final form. So as soon as they start talking about normal, I know I'm going to need to differentiate. So let's just crack straight on with that. So f of x is x cubed minus 5x squared minus 2, and then I'm going to rewrite the 1 over x squared as x to the minus 2, so I can differentiate. So differential of that, if you're using dy dx, that's okay. But f dash x, so I'm going to multiply by 3 and reduce the power by 1. I'm going to multiply by 2 and reduce the power by 1, so that's just going to become x. The minus 2 is going to differentiate to nothing. I'm going to multiply by 2 and reduce the power by 1. Okay, and then I want the gradient at p, so that's going to be the gradient when x is, not 1, minus 1. So that's going to be 3 times minus 1 squared minus 10 times minus 1 minus 2 times minus 1 to the power of minus 3. So that is going to be 3 plus 10 plus 2, I hope. So that is going to give me a gradient of 15. Just double check that. Yeah, so minus 1, so I have minus 3. Yeah, I think that's fine. Okay, so I've got a value for the gradient. So that is the gradient of the curve when x is minus 1. But this is the normal to the curve. So I want to use a gradient that's the negative reciprocal of that, because the normal is perpendicular to the tangent at that point. So if it asked me for a tangent, I would be using that value for my gradient. It's a normal, so I want the perpendicular gradient, the negative reciprocal. Okay. Right, I've got the x coordinate. I know that x is minus 1, so I also need the y coordinate. So if I work that out, so f of minus 1, so I'm going back to the equation for the curve, so that's going to be minus 1 all cubed, minus 5 times minus 1 squared, minus 2, plus minus 1 to the power of minus 2. So that is going to be minus 1, minus 5, minus 2, plus 1. So I get that as minus 7. Okay, so now I've got everything I need. I've got a gradient of minus 1/15. I've got the x coordinate I was given in the question, and now I've got y is minus 7. So I want the equation of a straight line. So I'm going to use y minus y1 is m times x minus x1. So y minus minus 7 is going to be y plus 7 is the gradient times x minus minus 1, so x plus 1. And then I want it, so I want it all equal to 0. So I am going to multiply up by the 15. I'm really lazy and stick that into my calculator. Okay, and then I'm going to be really careful not to lose the minus, so that minus there. So that's going to make those brackets minus x minus 1. I could have multiplied up by minus 15 as well. That would have been an option. And then they want everything over to the same side of the equation. So I'm going to add the x over. I'm going to add the 106 over. I'm going to just do a final check of the form they wanted it in. Yep, so I mean, they've got their x term first before their y term. I don't think no one's going to worry about that, but just on the safe side, let's rewrite it, but that's not going to be a problem. And then let's just double check our answer. Brilliant.